Hey guys, welcome. Today we'll be looking at data communication networks. And we want to discuss a few things relating to data communication and networks. So we want to know, what is data communication? So data communication is the process of transferring data from one computer system to another. So it's the process of transferring data from one computer system to another. Data communication is essential for sharing tasks and information. So if you need information to move from one computer to another, that is considered to be data communication. So let us look at network. So a network is a group of computers connected to share hardware resources and data. So the network basically is a set of computers, it could be two or more, and they are connected together, and their purpose is to share data and information. The hardware resources that they are referring to is like your printer or your scanner. We can share that resources that is there. So you don't need to have 10 computers and buy 10 printers. You can connect them in a network and share that resource. It also says that computers connected in a network can easily transfer data between each computer. So once you are connected on the same network, it is easy for you to transfer data. How is this process done? First, we need a network interface card, in short NIC. It's basically a piece of hardware that allows a computer to physically connect to a network. And that is a simple diagram of a network interface card. Next, we could look at the types of network. One, our local area network. In short, we use LAN, LAN network. Is a network of computers within the same area. Most offices, schools, and homes can use local area network, right? So you'll find that set up in those areas. Next, we could look at the second one as metropolitan area network. In short, MAN, M-A-N. It's a large computer network which usually spans an entire city. Metropolitan area network are used by universities and large companies. You find them mainly in those areas. The third one is your wide area network. So we move from that. So the third one is your wide area network. WAN, W-A-N. This type of network consists of smaller local area networks. So it's mainly local area networks connected together, which is going to form your wide area network. This type of network connects other networks across a large geographical area, such as a state or country. So we're looking at country to country connection. So let us look at how we get the information going. So it says computers can be linked in different ways to transmit data. So they could link first in a point-to-point connection, which is a direct link between two computers in a network. Example, a bus and a ring network. So we soon look at those type of topology. It also could be linked through broadcast. It says using one computer to transmit data and information to serve the needs of several terminals or computers. So we're referring to computers connected to it in a network. Example, a star network. So let us look at the network layout. So for your network layout or your network topologies refers to the configuration of cables computers and other peripherals. Other peripherals would have been your printers, your scanners, those devices, how we connect those on the network. So there are three types of layout. We have our star network, our bus network, and the third one would be your ring network. Let us show a diagram of those type of networks. So in a star network that we see here, the star network, all the nodes are connected to a central hub. So we have a central hub, which could be a switch or a router here. So we have a hub being set up right here. So everything is connected to this central hub. This means that each computer has its own connection to the network, and that a break in the cable will not affect the working of the other computers. If the hub breaks down, then all the computers on the network, so we're looking at the switch or the router itself, if it breaks down, then all the computers on that network will not work. So another point there is also that this type of network setup is very expensive to set up. If you look at the bus network over here, it says the bus network is the simplest type of network setup that we have here, where the network nodes are in a line. It is cheap, but if the cable breaks, the network is split into two unconnected pairs. So if it splits, then it's going to split into two unconnected pairs. It is also slower than your star network. So the star network is faster in terms of speed. And that is why most of our setup is like the star network. If we look at the ring network here, so it says unlike the bus network, the ring network has no end to the line. The last node is connected to the first node, forming a ring or a loop. And that is the setup that we have here, so we want to look more on transmission modes, right? So transmission modes could be one, simplex. So transmission mode is looking at how we are going to get data to flow, or how data travels. So the first one is simplex. Data travels in only one direction. As you see here in the diagram, data is going in one direction. Examples of devices are how data travel. We could look at our radio device, our television system. Data is traveled in only one direction, from the broadcasting station to the device. So remember now that simplex data travels in only one direction. The second one is half duplex. For a half duplex, data travels in both directions, but not at the same time. Notice in the diagram it can travel in both directions, but not at the same time. And if we could go back to some examples like our walkie-talkie system, where the security companies would use, when one member speaks, the other would wait. So he or she would say over, or you would say Roger, which would indicate that that person would have said all that he wants to say in that sentence there. So the next person could come in and say what he or she wants to say after that. So both of them cannot be talking at the same time. Or we could look at our city suburban radio, where you would see in most television series where the police officers would have these devices where they would speak over to headquarters on these. So they have to be waiting on the information to be sent in one direction and to return after. So data travels in both directions, but not at the same time. The third one would be full duplex, or if you want to cut it short, duplex. Data travels in both directions and at the same time. So you notice it says at the same time. So we can have data moving from both devices simultaneously and at the same time. Example could be your modem, or your modems, and your television, or your telephone. Right? So your modem allows data to travel in both directions, just the same way you can talk on your telephone system. Right? So we want to look at bandwidth, our final one now here. So the final one is bandwidth, which is different from our modes of travel. We want to look at bandwidth in terms of how much data can be transmitted at a time. For a set amount of information, the greater the bandwidth, the faster the information can be sent and received. So in essence, the more bandwidth or the more megabyte you receive, the faster you can send and receive data. So when you are going to your internet service provider, the more bandwidth you receive from them, the greater or the faster you can send information and you can receive. So you can download information from the internet faster, or you can upload information to the internet faster. And all of that is dependent on your bandwidth. So we are going to stop there for today. So please remember to like our video, subscribe, and stay tuned for more. Thanks for watching.